Hey, everybody, and welcome back to the Adventures in Machine Learning podcast. With us today, it is me, your stand-in host, Kent Laborde. And then, of course, we have the amazing Beryl. Beryl, say hi to everybody.
Hi.
Awesome. And today we are talking to Ken Youens-Clark. Ken, please tell me how terrible I was at saying your entire name.
Oh, no, it was perfect. You got it just right.
Oh, yes. See, I can be taught. See, this is machine learning in progress, everybody.
Reinforcement learning.
Supervised
Exactly. As I get beat down for, actually, fun story. I'm just going to start this off with this. I emceed a conference and I just stayed away from everybody's last name. It was the best thing I ever did. But then Yanni, even Kilo, oh man, I still can't say his name, called me out. It was the last talk of the entire time because I think Gant just called me Yanni and just avoided everybody's last names because he doesn't want to try to pronounce other names. He said that and the whole audience laughed. So then I realized I didn't really get away with it. But fortunately enough, all right, good. I'm still saying last names. I apparently got close to getting it correct today.
Hey folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Ken, could you do us a favor and tell us all a little bit about yourself and what brings you to this episode of Adventures in Machine Learning?
Yeah. So, my experience in machine learning is actually mostly limited to the class that I did in when I was doing my master's degree a few years ago. Really, most people find my path into even programming to be somewhat interesting. I started off in college so many years ago. 1990 is when I went to start my undergrad, and I was set on being a jazz studies major. So I was playing the drum set at the time, and getting out of high school, I really had no idea what I wanted to do. Programming was not even a flicker in my imagination. I thought I would become a musician. A couple of years of music school cured me of that. Really showed me that I was woefully unprepared for life as a musician. And it really helped that I was going to one of the largest music schools in the nation, the University of North Texas, with perhaps the largest percussion department. And so, I got there and I was like, oh yeah, I'm not going to make it. So I changed my major actually a few times, just kind of floundered around in undergrad, and eventually just got out with an English literature degree, simply because it was, something I could do. And still up to this point, hadn't ever programmed anything, with the exception of I did a little basic on a TRS-80 when I was a kid. I think I may have written all of 1.5 programs and wasn't really interested in it. And so got out of college, got just a job in, just an office job in just a regular old company. Was pretty miserable, hated it, was bored, and started playing around with databases with Microsoft Access. And this was 1995. I was learning, I taught myself some HTML, built the company's first website. I did that just using Notepad, learned how to use PuTTY to FTP files over. So just taught myself some basic stuff with a little bit of HTML and databases. And that led to a position, my next job, where somebody kind of took a little pity on me, saw a little promise, taught me Visual Basic. And from there, I was just kind of like, oh, this is really interesting. I really just quickly fell in love with, I really think, just the problem-solving nature of programming. And so just jumped around to a few jobs in industry, learned various databases and programming. I was mostly doing Windows desktop development software. And then around 1998, I was like, this internet thing is definitely going to be big. This is where I need to be. So moved into a company that was doing like ASP, active server pages and stuff. So up to this point, I had really just spent my career in Microsoft shops. And this was, Microsoft is a completely different company nowadays. This was back when they were fundamentally opposed to anything open source. Yeah, they were And Bill Gates was the devil incarnate back then. And I was just getting sick of Windows. I rediscovered Unix because I had a little brush with it in undergrad. That's how I did my email, was on probably a VAX server with, I think we were using Pine, right? Pine is not Elm. And so I had a little familiarity with the command line. I rediscovered that. I started buying, technical books, and I was interested in web development. And so late 90s, that was going to be Perl. So I taught myself Perl. That led to a job at Boston.com, which is the internet site for the Boston Globe. So I was working for New York Times Digital. So that was really cool. We were an entirely LAMP shop, Linux, Apache, MySQL, Perl. And did that for a couple of years. And that led to a job working for Dr. Lincoln Stein, who at the time, he was a pretty renowned Perl author. He had written some books. He had written some of the modules that were standard to Perl. And I saw that he was hiring. I didn't know what he did. I just wanted to work for a really cool Perl guy. And he brought me into his lab, and I discovered this field called bioinformatics, which is biology plus computer science. So, I didn't know any biology. He patiently taught me over the years enough biology to be dangerous, to be able to write the programs that he was asking me to do. And so I stayed with Cold Spring Harbor for 13 years. And in 2014, I left that and went to the University of Arizona to join a former colleague from Cold Spring Harbor who had started a lab. She'd gotten her PhD, so that's Dr. Bonnie Hurwitz. And so she was my boss for the next 6 years. So I went from working in plant genomics at Cold Spring Harbor to working in what we call metagenomics, which is essentially genomics of the genomics of unknown communities of organisms like microorganisms, fungi, viruses, bacteria, archaea. And so that's what I did for the last 6 years. And now I'm currently working at a nonprofit in Tucson that is focused on trying to find new therapeutics for rare diseases, of which there are about 7,000 to 9,000 rare diseases that affect a total of perhaps about 10% of the population. Rare diseases are a problem because they don't present enough patients for drug companies to really go after, for a market. So that there's a lot of drugs that just don't have any in treatment. So that's what I'm currently working on. So, mixed in there, I've done some machine learning, but really, I think what brought us together here today is during my tenure at the University of Arizona, I had a chance to do some teaching in the classroom, teaching biologists some basic programming skills. And when we started, Dr. Hurwitz and I were using Perl because that was kind of our language of choice. But after a couple of years, we switched over to Python because Python really has taken over scientific computing, especially when it comes to, a lot of the standard modules for machine learning with scikit-learn and TensorFlow and all those kinds of packages. And so the question was like, how do you teach well? How do you teach people to program so that they actually understand what they're doing? But also, crucially, in scientific computing, how do you teach them to create reproducible programs? And so the solution that I really found worked well, both for teaching and for creating reproducible software, is to use test-driven development as a pedagogical technique. And so every exercise that I would present to my students was basically, here's an existing test suite. You have to write a Python program that satisfies these tests. And so using that formula over, a few years of teaching this, I finally decided to put it into a book form, and that's called Tiny Python Projects. So the idea of the book is to introduce Python as a language. It's kind of meant for a beginner, but if you don't know what a for loop is and a variable, you're going to be a little lost. And it does move a little quickly. I would imagine this would probably be like a second or third Python book. And while I may basically make no assumptions about your level of knowledge of the language, so I really try to explain what a list is and what a dictionary is and all these things. Really, the focus of the book is on getting you to think about how to first write tests and to have tests and to think about writing software, writing functions, writing programs that satisfy those tests, and then running those tests over and over again. And then once you have a working program, using those tests to refactor your program, to find ways to improve it. Maybe you shorten it. Maybe you can make it go faster. Maybe you can just make it prettier. So, but always coming back to those tests to make sure that you've actually written something that works. And the way that I teach how to write something that works is that the programs need to be parameterized. So basically wouldn't allow my students to have any hard-coded values in their program. So, if it's supposed to process a file, that file is an argument. And then the tests will feed the program at least 2 different files to verify that it actually processes the given file. And I teach using to create the parameters to the program to use the argparse module, which is standard to Python. And the benefit of that is that not only does it validate the arguments, but it also creates documentation, which is another key aspect to creating reproducible programs. Like, it is definitely the responsibility of the program to produce its own documentation and to validate that, that the parameters at runtime are correct. So this is, I try to teach all these things in the book, but the book also attempts to be somewhat lighthearted. I drew my own little cartoons, Actually,
nice.
Actually, Beryl and I were talking, just before we started speaking about Felina Hermans, who's another Dutch researcher. And she also incorporates a lot of crudely drawn, hand-drawn images in like her slides and her presentations and things. And I just think that those kind of human elements soften these technical kind of concepts that you're trying to get around. And so the book is meant on, I have teenagers, my children are teenagers. And so, I'm thinking about that level. Like, could I get a teenager even mildly interested in learning Python and test-driven development if I make it kind of humorous and interesting enough? So
Nice.
That was what, me just talking for 10 straight minutes or something.
Well, that's always best in a podcast. So I'll say, Ken, I love it because there's so much great information, and we're going to go back and unpack some of it. If you said, "Yep, I like to code," and that was all you said, this would be the shortest, worst podcast ever. So I appreciate the all the information. That's fantastic. Let's go back to the beginning on it for a second here, and let's get back to it because you said some part. Well, first of all, you said you were into jazz. And as a part of, so I'm from New Orleans, so there's a special place in my heart here, and then you end up in Tucson, so we get pretty close on this.
Yeah, I'm actually from Jackson, Mississippi.
Oh, yeah. So is Nader Dabit, who used to do one of the podcasts. He still lives in Jackson. I'm not sure though. To check that. So that's really awesome. Yeah. If you're listening here and you're unfamiliar with this, it's Mississippi, New Orleans, all the south of the states, and people learn a lot of stuff, and then we usually move away.
Yeah.
But I stayed here. Yeah, I taught a AI to play jazz music.
Oh, nice.
The reason I did that is because no one can say that it's playing it poorly. No one knows it's jazz. So.
It's like in Spinal Tap when they decide to reinvent themselves as a jazz odyssey, and they're like, they're just playing notes. That's all they do is just play the wrong notes.
But these go to 11. So perfect. So you went from jazz, and then you started doing some Access. Working with. So you started getting into Microsoft domain with Access, Basic, VB, which, by the way, I think is a totally valid process. Beryl, have you ever done any like Microsoft? Have you ever done Visual Basic? If not, you've missed out. And I know you said
no. I'm mostly using Python. No.
See, you were cool right away. You have to understand, we over here, a lot of us had to start with terrible stuff and then just trying to have a good time making Access do something fun, Visual Basic, and then like ASP was really awesome, by the way, Ken. So I love the path that you took going forward. Because then they released ASP.NET, which basically says like, you don't know ASP anymore.
Yeah.
Which is what happened to a lot of us. And meanwhile, Beryl was just doing Python the whole time, happy, and knowing how to do something, a language that's not going to change every 5 seconds.
Well, actually, I was thinking I'm a little bit feeling sad in my university education. Everything was so much theory. I mean, it was very nice. I really enjoyed hand calculating 5-10 pages of mathematical equations.
Wow.
Without any programming, doing all the electromagnetic formulas. It goes 10 pages to find the result, and we all hand calculate this, no programming. And I
Wow.
had to learn programming so much later in my studies. So it was not really an education focused on programming, but an education focused on mathematics and theory. But yeah, I hope things are changing these days at universities. So at the programming side, I'm a little bit self-educated, I can say as well. Yeah.
Well, if you were in Ken's class, you had like lots of cool exercises with cartoons as you were learning Python.
Well, I'm looking at the book now. It looks so much fun. Did you draw those drawings yourself, by the way, or somebody else?
Yes. No, I did. When I was working with Manning to create the book, they said, "Don't worry, we'll have an artist, redraw everything and fix all your, all your diagrams." Yeah. And then at the end, they just the publisher decided he liked my drawings, so they didn't redraw them; they just used them.
It looks like you really enjoyed writing the book and making the drawings, and when somebody makes really fun when he's or she's making a work, it's also so much fun to look at it and get engaged with the author. I really
thank you.
like your work.
That is awesome. Yeah, if you're listening right now, go ahead and take a look. The book is Tiny Python Projects. It's a Manning publication, and then it's going to be Ken Youens-Clark.
There are so many examples also within the book. Yeah.
Yeah, the book is designed to. The progression that I go is, we start off with essentially kind of a hello world, just like string manipulation. So, given some word, you have to decide whether to put the English article a or an in front of it, depending on whether the word starts with a consonant. So actually, it's been interesting having non-English speakers read the book. So I have an English background, right? English lit. And so I really have a love of language, which I think is something that has made me just kind of collect programming languages over the years. I just love learning languages.
Information between.
Yeah, I find linguistics
education. Yeah.
And so when I explained this in the book, like given a word like octopus, you have to put the English article "an" in front of it. So it's an octopus. But if it's submarine, then you have to put a submarine. And a lot of non-English speakers are like, "Oh, I didn't realize that was a rule." Like you just kind of, you hear it because it's the liaison in, that joins phonically joins two words like that. But so some people thought that was just interesting to learn that. But then like programmatically, how do you decide what is the first, how do you classify the first character of a letter? Well, in Python, how do you even get the first character of a word? So, you get immediately into like indexing, like using the in, like is this character in this set of vowels or consonants? And then, so once you've classified it, how do you choose the correct article? Then how do you create the string to print to the output? So that's kind of like, that's the first exercise. And then the second exercise introduces lists. The third exercise introduces dictionaries. The fourth exercise introduces reading and writing files. And then from there, we just start building up, start introducing ideas of like regular expressions, which is, I feel like I was probably programming for 10 years before I was introduced to regular expressions. So I try to bring that out right away. Like, hey, there's this whole interesting field of research that's decades old, comes from linguistics actually, called regular expressions, and they're incredibly useful. And we use those all over the place. And then I start, because these are really intended to be kind of fun, interesting games and puzzles, I bring in randomness. So there's the random module in Python. And this actually, I learned a lot about in my machine learning class. So, if you're going to, do a Monte Carlo simulation, and you're going to write a reproducible analysis that uses randomness, then you have to learn about random seeds and like how to seed your algorithm, how to seed your program, so that when you're in a testing environment, you can verify that it's doing what it's supposed to do. And then you take the seed away and then you get, pseudo-random number generation. So, introducing these ideas throughout the book, building upon them to the end, all the while using testing, all the while trying to combine these skills so that at the end, we also by the last chapter, I start introducing things like type hinting, which is something that's new to Python. I think 3.8 or no, maybe 3.6 is when they started introducing type annotations. And so how can you use types to, in addition to testing, to write really solid programs that documented, are reproducible, and like I have to use my own programs, right, that I come back to 6 months and a year later, and I wrote them and I look at them and I can't remember writing them. And the first thing that I do is I'm like, okay, how does this program run? Let me see the help documentation. Let me look at my README file. Let me look at my make files that I've put in here to help me remember how to run these programs. Without these crutches, these things that I use, I would not be able to go back and reproduce work that I did 6 weeks ago, 6 months ago.
Yeah, I think that's it's a good point. There's people say, "Oh, well, I'm working on a project by myself. I don't need to write tests and comments and docs." And it's like, you need to write that for yourself 6 months from now.
Absolutely, you'd be completely lost without it.
So good that you're enforcing a good structure there. And I know a lot of people are looking to get into machine learning who haven't touched Python before. So your book is a perfect aspect of, like, hey, I'm looking to getting into machine learning. I'm interested in getting these different parts, but I've never coded in Python. I think that this serves as a great friendly option, because you have exercises and you have them in these fun, almost riddle-like skill sets. And I love that. And then you have the tests, so you can identify, what the problem is and kind of come back. I think that's really important, especially for someone getting started, is to clearly define the problems and then clearly define that they've actually come to a solution. And that's not easy to have.
One thing I would say, my experience practically of having programmed now for about 25 years, and I've done a handful of machine learning projects. Like I said, during my master's, that was really interesting. And also, I would say that my machine learning teacher was really focused on making us understand the math. Like, it was really a linear algebra course, and there was some programming, but boy, he really made us understand that. And so I think truly machine learning is, first off, really understanding the mathematical underpinnings of these different models. But also, I mean, wouldn't you say that a significant portion of any machine learning project is just simply cleaning up the data? Just like you get messy files, like I was saying in bioinformatics, a lot of times I could try a couple of machine learning projects on metadata. So the data in genomics is going to be sequence data. So, ACs, Ts, and Gs, the DNA from these various organisms. And you can do a lot, an incredible amount with the genomics, with the data, but you can also do a lot with the metadata. So, say you're trying to study organisms, microorganisms in the ocean. And so you might want to correlate, for instance, the depth that these samples came from, the temperature of the water, the latitude, longitude, the latitude especially of the kinds of waters that these came from, the amount of oxygen in the water, all this metadata that would really drive what kind of organisms are living in that environment. And that metadata is incredibly dirty. It's such a mess. People, especially in biology, can barely be bothered to put in the metadata. Like, you might be lucky just to get the latitude, longitude, and maybe the depth. But like I was doing a project where I was simply looking for 4 points: depth, latitude, longitude, and temperature of the water. Just, you would think that those 4 basic data points would be included with every ocean sample. And like only about 60% of them were. And then the latitude, longitude are in at least a dozen different formats. There's no standardization for the data libraries for how to put that data in there. And so it was really just writing dozens of regular expressions to find the data that I was looking for, to finally get it into a consistent format that I could then go and do some machine learning on. So without a solid understanding of how to write, Python or Perl, whatever your language of choice, to clean up these data files and create the data that you're looking for, you're not even going to have something that you can use to ask a question.
You worked in biomedical data. That's a quite different field than, most of the examples that we are looking at. Do you really need to learn a little bit biomedical domain before diving into any problem, or the domain is not relevant? Whatever data comes, you can, when the task is clear, you can extract information, clean the data, and achieve results. How do you look at data, and especially when it comes from many different fields?
Well, I spent so much of my time in bioinformatics, and unfortunately, I'm not in that field right now. I'm actually more in biomedical at the moment. And with my background being like mostly in humanities, at the University of Arizona, I was able to complete my master's degree. So I finally feel like I have a little bit of credibility there. But still, I'm not a trained scientist. And so, when it comes to like interrogating especially genomic data sets, I have to be paired with a PhD level researcher to know what to write. That's an incredibly complicated subject. And some people just know that that's what they want to do. And so, like I worked with one really fabulous undergrad who had just studied computer science and biology as a double major. And then was working on his PhD in our lab. And he was just, set for a career to essentially do all this kind of work himself, like as a PhD level researcher. With my training, I really need to be working with someone, and because I'm just really fascinated with programming and programming languages and databases and web development and all this stuff. And there just really isn't enough room in my head to also cram in a full other domain of like biology. So, it's a super intimidating subject too. Like, you think you know what you're talking about, and then you go sit in on some, seminar and you realize I can only understand half the words they're saying. And so I think that in general, that's just our field, is that, you might know a lot about one particular language, and then if you do like web development, and then all of a sudden you start talking to database people and you realize you're out of your league. And so we're all like that, with all of our domains. It's just a constant learning cycle that you're just constantly trying to learn what's the next greatest thing, what's going to make me more productive, what's going to be easier than, what I've done in the past. So, I think that I'm answering your question. Essentially, I feel like I need a lot of guidance still to know how to write a program that actually does anything useful. I can write the program well and I can make it reproducible and I know how to write tests for it, but is it going to be useful, for some domain? And in bioinformatics, that, it was really fascinating, working at the University of Arizona, because I had an opportunity to work with so many different researchers to help out, their students or their projects. And so, but, somebody would, one of the projects came to me, it was a virology lab, and they were trying to annotate new human papillomavirus genomes. And I'm like, okay, teach me. I have no idea what you're talking about. And so, I just have to sit down and learn a whole new domain and a lot of new ideas, and then try to explain how to put those ideas into code, and then to write tests, and then to verify that we're actually doing this correctly. And then, it's a fascinating field. And I guess that's all I have to say about that. Sorry.
Perfect.
Hey, folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there, The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
Yeah, I saw in the book. So funny enough, it's getting data. The way we perceive things as humans doesn't mean that we have data. For instance, I saw, to just kind of browsing through the chapters, you have a section on tic-tac-toe. And so what's really funny is actually I did something about tic-tac-toe. So I had this moment where I had to figure out, how do you encode a game, And I think that by itself, you have this interesting moment. You have to know not only like the rules, the plan, the state, the information of it, but you also have to know what the outcome of why you're encoding something. Like, does this need to be so a person could play it? Is this so an AI could play it? And then what I really love about this is like each person has to really ask this large group of questions. It's 9 spots. It's just 9 spots. But you have to ask all these questions before you can do your very first encoding and figure out how you're going to tell a computer to maintain a board state. And that by itself, that that's the data scienciest of what's going on there. And then someone comes along with all these, bioinformatics, and I think you said you're in medical informatics as well, where there's MRI data, there's different formats of MRI, there's different machines that are out there. And so if I were trying to scan a brain, that's a little bit more than 9 spots. I couldn't imagine. I can't even. You and me, I guarantee you, the way you encoded your tic-tac-toe and the way I encoded my tic-tac-toe were different.
Absolutely.
How do you standardize that? So you were just saying those 4 points from earlier, they're all over the place, and you had to write regular expression, which we have a saying at my company: you used regular expression, now you have 2 problems. But the fact that it's not simple. Like, you need to be very quick in solving, testing, identifying, and clarifying what the actual state of this is. And I think that's part of what the way your book is handling these things. It's fun to hear that you're taking that sort of mentality to this next level where I can't even picture what it must be like to take bioinformation and have to sit down with someone and then figure out how to manage that kind of data. I don't envy it, but it sounds like you might actually be having fun with it. I don't know.
Yeah, it definitely, it's always a challenge. And I find I just get bored without challenges. So, I appreciate that. I appreciate that you brought up the tic-tac-toe. And I would say in general, where I was going with the exercises in the book is that I was trying to make them short enough that I could cover them in a 1-hour class. So they're all meant to be teachable in an hour or so, that you could write a solution. And I've also got videos on TinyPython.
Oh, wow.
So if you go to tinypythonprojects.com, there's a link to all the code, all the tests. The GitHub repository is completely open and free. You can download all that. Each chapter has, between 5 and 10 videos that step you through kind of teaching you the background for the problem. Like, if you don't really know what Python lists are and what you can do with them, I try to show that to you and then give you hints as to how you would use that information to solve it. And then I go through usually a number of different solutions for each one. And so the idea is that with each puzzle that they're simple enough that you just know what they are, like Mad Libs. So I have an encoding of Mad Libs, which maybe Beryl doesn't know Mad Libs because that's like a very American game. Are you familiar with this, Beryl?
No, I'm not.
So it was a game that we had. I mean, we still have them here, but I grew up in the 1970s and 80s, so way before computers or anything like that. And so it was this sheet of paper, and it takes 2 people to play the game. And one person looks at this story that has all these essential words left out, and they're just the part of speech is there, like adjective, pronoun, noun, number, things like that. And so one person would ask the other, give me an adjective, give me a noun. So it's random, right? This person's going to just say random, like shark, fart, hot dog. It doesn't matter. And so then you fill in all the blanks, and then you read the story back. And
you make a random story then.
Yeah, you make up this story that has these random words thrown in. And it's, especially for an 8-year-old, it's pretty damn funny. So I encode a Mad Libs, right? So there's this file that you have to read that, has these placeholders for adjective, noun, things like that. So you create a program to ask the user for those inputs, and then you substitute in all the values, and then you spit out the resulting text like Mad Libs. And so, you could write this program any number of ways, but the ground truth is in the test. Can you write a program, however you write it, you have to satisfy this test. And so I think that allows for a lot of creativity and flexibility in the solution while still grounding the student, the reader in like, you actually have a task to solve. And it's this. And once you solve this, once you've just passed this test suite, you're done. Like, that's it. That's all you have to do. And so I think that really helps a person learning to focus on what they're trying the problem that they're trying to solve. And the last two chapters of the book just are on tic-tac-toe. And I know, like, everybody does tic-tac-toe. And I think everyone should do tic-tac-toe. It's just a good exercise. And it's surprisingly complicated. Just like you say, there's only 9 spots, but you have to, like, how do you represent this 3x3 array? Like, are you going to do it as a list? Or are you going to do it as a dictionary? It doesn't matter. I mean, just, you have to come up with something that works. How are you going to decide if an X or an O can go into a spot? Like, the second to last chapter is you just play one round. So just like one hand, like, given a state of a board, can I make this play? And then has someone won? And then the very last one is iteratively an interactive game that just plays in the terminal. So these are all just terminal-based games. How do you represent state? How does state change throughout the program? What are the things that you have to track? Like, is there a winner? What's the current state of the board? Was the last thing that you gave a invalid entry, like, that you didn't give a number for the square, or you gave a string instead of a number? And so, who's the current player? All that has to be tracked as the state. And so I show one way to do that, but ultimately, yes, you could do this. As many different programmers try to solve it, there will be that many different kinds of solutions, which is frustrating. But it's also, I don't know. I really think about the idea of, like, there's not that much creativity in building bridges, right? And bridges stand up for decades. And I feel like we definitely have this curse of irreproducibility in software, because there's as many different programmers, there are as many different ways to solve a problem. And that's not always great.
Yeah.
It doesn't necessarily lead to programs that stand up.
What keeps you most excited these days? Is it the beauty of algorithms, or challenge with different data sets, or teaching this programming to young people or people who are coming from different backgrounds? What keeps you motivated and excited?
Well, unfortunately, I've had to leave my position at the university, so I'm not going to get a chance to teach anytime soon. Although I'm trying to work different ways, maybe to get back into some sort of a teaching gig, maybe at a local community college or something. I'm actually writing a second book with O'Reilly. It's called Reproducible Bioinformatics with Python. So pretty straightforward. That's what it's about. And it takes the same problem solving approach to there's a website called Rosalind.info, named after Rosalind Franklin, who should have won a Nobel Prize for her work in discovering the DNA structure, but Watson and Crick stole her work and got the Nobel Prize, and she died young. But it's a series of bioinformatics challenges that start with, given a string of DNA, tell me how many A's, C's, T's, and G's you find. So it's kind of the hello world of bioinformatics. And it builds up from there, like, how do you create the reverse complement of a string of DNA? How do you find all protein sequences from a string of DNA, both forward and reverse? And it's really a fascinating introduction into biology and bioinformatics. And so I use those with the same structure as Tiny Python projects to introduce, like, how would you apply those same test-driven ideas to the field of biology? And so that's been something that I've been putting a lot of work into the last few months, is writing this book. I again see this as a text that could be used in a classroom environment to teach bioinformatics to people new to the field. Again, I feel like each chapter is short enough that you could go over it in a class, or it could be the basis for a take-home assignment. And so that's something that I feel very strongly about, that there's a lot of people interested in getting into bioinformatics, and there's so many different ways to do it. Like, most people in bioinformatics are either computer scientists who have to learn biology, or they're biologists who have to learn enough programming to be dangerous. And so it's a real crossover field. It's very few people who are actually formally trained in both domains, or I say both, it could be several domains, and it depends on whether you're doing like oncology or image and some of the fields are going to be, like you say, looking at MRI scans. So that's going to be really more machine learning kind of approaches to figuring out, like oncology scans or something like that, which, by the way, I think they've shown that pigeons can be trained to identify tumors better than oncologists. So we actually have quite a ways to go. But, that's going to be a very separate field, very different field from, say, genomics, which is going to be really a lot more text-based, linguistic approaches to finding patterns and sequences of DNA. And so it's a huge, huge field, and there's so many ways to get into it, and there's so many different things to do inside the field that I really foresee probably spending the rest of my career in and around bioinformatics, biomedical kinds of data. And so, but I think it definitely is about training and mentoring is perhaps at least half of my focus. I really want to see, I've seen a lot of bad code, just a lot, from working with, young programmers and postdocs and people just new to the field, especially coming from Perl. I feel like I wrote Perl really, really well, and I used all the best practices I could. But boy, you can write some really atrocious Perl. Like that's some people like to call it a read-only language. I mean, a write-only language, just because it can't be read. But honestly, that you could write really bad code in any language. It's not that difficult. So I think that no matter the language that you're working in, I think it's very important to learn basic principles of how to use, tests, how to use how to create documentation, how to parameterize programs, how to use types, which is, something that I've learned a lot in working with purely functional programming languages like Haskell and Elm. I've done a fair amount of web development using Elm, which is a really, really interesting language. I feel like that's fundamentally changed my approach to programming. And so another thing that you may notice about Tiny Python projects, and also about the code that I'm writing for the second book, is that I take a purely functional approach to Python. I completely avoid object-oriented programming. I find that functional programming, I think, tends to lead to simpler programs that are easier to test and easier to understand. And so that's something that I'm really advocating. Python is this really multi-paradigm kind of language. You can write object-oriented, you can write imperative, you can write recursive, you can write functional, and with the addition of types, the type hinting over the last couple of years in programs like MyPy, it has really taken the language to another level. I think it's been a huge improvement. Sometimes I feel like it's a day late, a dollar short, like it's not quite good enough. But it's certainly better than not doing it. It's like saying, well, a test can't prove that a program is bug free, so why should I write tests? Well, I'm like, well, why wouldn't you write tests? I mean, it's really the bare minimum that you ought to do, especially with a language like Python that's so flexible to a fault, that if you're not writing tests, especially in the scientific domain, then you're just not doing your job. So I would say that advocacy for training on how to write in any language, like I was on this one project over the summer, it was completely in R, which I honestly detest the R language. And everybody on the program, everybody on the project was basically a scientist who had picked up R in graduate school at some point along the way. And no one had any idea really how to write software, how to write tests. And it was this classic house of cards, like programs that have been around for 10 years, and you're not allowed to change these programs because it would have this ripple effect throughout the whole project, because there's not a single test in sight. And so people would have no way of knowing, if they changed this one thing, how many other programs would be affected. And it was honestly a nightmare. And so, when you see stuff like that, projects that have gone on for, a decade with millions of dollars in funding, and you look at it and you're like, this is all unreproducible. This is not going to be useful at all. And it just kind of makes me cringe. It makes me sad. I'm like, that's a huge waste of space and money and time, that if somebody had come in with some good testing principles, just some good architecture ideas at the beginning, it wouldn't have gone, this badly. So, those ideas, that's, I think, if I have any sort of a lasting legacy in any way, I would hope that somebody might pick up my book one day and say, oh yeah, tests, they're not that hard to write. And actually, it makes me feel good because I know that my program is actually somewhat, provably correct.
Nice. Yeah. It's good to see, test-driven development, functional programming paradigms start to be, instilled in people who are getting started. It is, I feel like it's a balance, this sinusoidal wave of, tests are amazing, functional programming is amazing. And then sure enough, then there'll be a wave of people just ignoring it for some reason. And then everybody feels the pain and they come back. So it's good to see that you've got that sort of at the root of what we're showing people.
And, I came up through the heyday of object-oriented programming in the 90s. That's when I was getting my start. And Visual Basic was not an OO language. And my next language was Delphi, actually, Object Pascal from Borland. Wow. And that was very, very object-oriented. And I was just like determined to learn. It sounded so sexy, it seemed so like intuitive in its own way. And then after years and years of writing OO stuff, I was just like, I discovered functional stuff. I'm like, oh no, I hate object-oriented. Like I haven't written another object-oriented kind of solution in probably a decade now.
It was, I think, an important growth step for everybody. I'll say procedural programming was just, especially since you said you came from basic, and especially Visual Basic. For a good bit, people you needed to go through object-oriented programming like you needed to go through your teens.
Yeah.
It helps you actually appreciate your family or a couple of other things that you had to leave for a couple of years to come back and actually do it. It was your year abroad. That's object-oriented programming.
Yeah. For me, it was like 10, but yeah.
Yeah, it was, we just condensed it down. For all of us, it was 10, I think.
Yeah. But truly, I don't teach object-oriented programming in the book. And yet, if you don't have that understanding, then you're going to be really lost, because Python is an object-oriented language. Like everything is an object. So, what is a function versus what is a method? Do you understand, the kind of the container idea of an object that has this internal state that sometimes you can mutate and sometimes you can't? Like one of the things that's extremely frustrating to me is that there's two ways to sort a list in Python. There's the list.sort method that mutates the value in place internally to the data structure. And then there's the sorted function that does not mutate the state and just simply returns a new list. And so, that's really hard to explain to a beginner. And I think that to an extent, purely functional languages are easier to understand because you don't have to try to make them understand that this list is this object that has internal state, and that the sort method. And I always have to, am I saying function or method? But the sort method returns none, right? And so you're calling it purely for a side effect, and then okay, now I have to explain what side effects are, right? And so, I think it's frustrating. It's a little bit frustrating with Python because it does mix all these different ideas. Whereas in a purely functional language, there are no side effects. Every function has to return something, and it can only ever return the same thing. But in Python, you can return, a function can return a string under one condition and a number on another. And then how do you use that sanely? So these are some of the ideas too that I'm trying to teach in the book.
Well, it is a progression. I think that some languages were mixed in a terrible way, just in the early 2000s. And now you have languages sort of carrying on saying, we're not going to pick sides between object-oriented and functional. And they are... sometimes they're dragging things along, like in JavaScript, we're dragging along double equals, triple equals. So I guess there's, really everybody's in a glass house at some point because, these languages are, I think that's beginners come into this and they're like, why why is this all over the place?
Yeah.
And, each thing brings its own history. Sort of like each data that gets, converted over was collected differently, was brought in differently. So as we think in these analytical sort of philosophies, we've got this real world trailing behind it that's always ready to come in and let us all know that we've got a lot more work to do.
Yeah.
Yeah. Ken, this book is amazing. You've made it on a list for me to help people, because I do have people reach out often and they say, look, I'm programming in X and I need to start programming in Python. And now I know that I can be like, hey, tiny Python projects. This is where you start. You've got everything lined out for you. And then the fact that you've got videos, it seems like, that sort of teacher-esque, that didactic side of you came out of this. And I'm glad that you're writing another book, because that actually means you're still embracing that aspect of like teaching people and structuring information. I guess that's what leans a lot of people into machine learning and data science as well, is like all these things is making sense of information. And that seems to be something that you've done really awesome here. So I love that. And actually, I wonder, how long has the book been out for, by the way? Has this been around for a bit? Because now you're working on another one. So how has it been received? How's it been around for a while? How's that?
The early release was earlier this year, and then the book was published. I think it came out in like August. And so it's really just come out this year, and
Perfect.
I anticipate my next book to be out next year.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams, or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming. And I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
Awesome, Ken. That's fantastic. I think we're running short on time now. So what we'll do is we get to this last part of the podcast where we do this thing called picks. And in picks, we basically ask people if they have something that they'd like to mention, and it doesn't have to do with programming at all, or it could be with programming. Beryl, do you have any picks for us today?
Yes, I have a pick. Today I made a video recording with my dear friend Carlo. Carlo is from Eindhoven University, and he's a genius. He's a Kegel champion for many times in many different competitions. And we've gone through a code example together. We made a recording and we used some explainable AI tools to describe what the AI is learning in the algorithm. And if it's not learning well, how to fix things. We had a discussion. So it's going to be on YouTube soon after editing. I'm leaving my channel link, and I hope people find it interesting.
Awesome. Very cool. Very cool. And so next, I'll go with myself for a pick here. I was a good one of our panelists who come in sometimes, and also past guest, Jason Mays from Google, did a TensorFlow JS wrap. And it is pretty entertaining to watch. And I have a cameo in it for just a second there. So I'm going to put that in the links. So if you can watch the TensorFlow JS wrap, and if you want to, you can look for me to be in there. It's quite entertaining. And I think that I really do enjoy the web plus AI world. It's building pretty entertaining stuff, which is cool. And Ken, do you have any picks?
Well, definitely not having to do with programming per se, but I have loved watching The Queen's Gambit on Netflix.
Oh, I started it last night.
It is so great. It's such a well-made show, and I think that it's based on a novel about a young female chess prodigy coming up through really late 50s and the early 60s, and so in a field completely dominated by men at the time, and so really tracking what it would have been like for this fictional character to break into this world, and she becomes this grandmaster, wins at the end of the book, of course. And but I think it also really touches on ideas of tenuous nature of our sanity and how we can become obsessed with problems. And I know that I think all of us in this field understand that the idea of flow, when you fall into that state of mind when you're programming and just the ideas are just flowing out of you. I know sometimes people will describe a program that they need written, and it's just completely composed in my head. It's the struggle to type it out as fast as I can and to give it to them because I'm so excited to create this. And so it was fun to watch that in this character, but she's obsessed with chess. And it also like goes crazy and like gets addicted to pills and drinks and has a lot of psychotic episodes. And so I think it also points to the need for all of us to stay grounded as humans, to have relationships and to be outside and to engage with nature and to be a whole human and not to just be this savant.
That's awesome. Fun fact, when I learned chess when I was in school, very young, and I was never like the best at it, but whenever I went to competitions, I would go undefeated for my seat. And the funny thing is, I was just good enough to be dangerous in it. And then I met a friend of mine completely by coincidence, and he was the state chess champion, and he was doing a simul where he was playing everybody at the mall. And he had no idea, but I had researched a ton on a chess trap just so that way when I went to the mall, I could beat him.
And did you?
The whole thing. Yeah. So here's what happened. I researched the chess trap. He fell right into it because he thought there's no way that this guy knows how to go ahead and see this all the way through. I did know how to see it all the way through, and I got ahead by a rook. It was a significant advantage. And then what happens is, I don't know if you know this, but like as he defeats more and more people, he comes around faster and faster and faster. So after the chess trap was over, the game was going faster and faster and faster, and I couldn't like finish him off. So but he had no idea that I was running out of gas, and so I just go, "Hey, do you want to go ahead? You want to take a stalemate? Like you want to do a draw?" And he goes, "You're going to give me a draw? You're way ahead on material." I said, "Yeah, I'll give you a draw." So, so he shook my hand. The second he shook my hand, I was like, "Gotcha!" I was done. I have no idea. If you kept playing as fast as you were playing, you were going to defeat the hell out of me, even with a head on material. So yeah, pretty fun story. So I tied the state chess champion in a simul, but the truth is if we had continued to play that game, I put my odds at 50-50. I would have totally messed it up and he would have gotten me.
Nice. I appreciate that you did that.
Yeah. Chess is like one of those games where you can do that. You can sit there and just plan out some terrible thing, and it's you're playing the person and the board,
Yeah.
So by the way, I've watched the first episode of Queen's Gambit. I can't wait to watch the rest of it. Now I'm even more excited. Ken Youens-Clark, thank you so much for being part of this podcast, for inspiring people, for continuing to inspire people. We'll be bringing back your book whenever we can. I think that this is a super cool adventure. And then let us know, by the way, check back in with us when you release your next book with O'Reilly. And either Beryl or I will make sure it's our pick so that everybody knows that you did another book as well.
Great. Thank you so much.
Yeah, absolutely. Thanks so much. And that's all the time we have for today. Thank you, everybody, for listening. And from all of us here at Adventures in Machine Learning, See you next time.
See you. Bye-bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.